Hi my friends, today we demonstrate every tool which can be used to model sheet metal parts. We start by opening sheet metal template. We respect the sheet metal defaults. For instance, the thickness of 0.5 millimeters, and we want to demonstrate how all these tools are used to create sheet metal parts. Start a new sketch in the plane XY, a rectangle, finish sketch, and the most usual tool is face, which works if close contour is in a unconsumed sketch. This was an unconsumed sketch, and now it is a volume. A volume with the thickness 0.5 millimeters. Now we create another plane based on this face and this line at this angle, this angle, okay, where we create a new sketch, a close contour, like this, close contour, close, 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 finish sketch, a close contour in the new plane. Again, face, okay, and now it looks like two bodies, but it is only one. You can see this here where the number is 1. Now we edit the second sketch by applying project geometry, this line, this edge, to be in the plane, and alignment, this line collinear with this line. Finish sketch, and we see a very interesting thing. The two bodies, apparent two bodies, are now together, and a bend, this is a bend here, with the cuttings and all it needs. This is the tool face. Now the tool contour flange, we already know it, but let's try something else. In this plane, a rectangle, face. Now I select this side, and I start a spline interpolation. 1 with this shape, very interesting shape. This here I'll make it tangent, this to this, finish sketch, home, and I activate contour flange, selecting this profile and selecting an edge. As you can see, the future is suggested here. Yes? Okay, let's see the future. Oh, the other side. Double click here and I select the other offset direction. Okay, now it is connected. Okay, and this was the contour flange. We used it in the previous tutorial. Another tool we know is flange. We start with a rectangle, close contour, like this one, and then face. Okay, and now flange. I choose this edge, the angle is 90 degrees. I'll change it, but I want to make this these two icons for height datum and pen position. They are very usual. Okay, now I'll edit this part by selecting all its sides, and we have this 4 flanges around the part. We can change the angle to be 100 degrees, and now the part is, as you can see. We can create pattern. This is the pattern. Again, we start now by creating 2 sketches. We want to demonstrate the lofted flange tool. Here we create a rectangle, but this kind of rectangle with these proportions and with the round corners like this. Finish sketch. Now a new plane based on XY, XY at a distance. Here we create a circle, finish sketch, visibility, and now the promised lofted flange. First sketch, second sketch. We choose not this press break solution, but this die formed solution. OK, and you see the result. Transfer from rectangle to circle. Very nice. We can demonstrate now the rip tool. We have the rip tool will create a cut along a generator of this volume, of this sheet metal part. We want to cut it on this face, and we choose a point, this point, and we have the rip. This is useful because you want to create the flat pattern, create flat pattern to know how to make the part. I go back to the folded model. Next is the tool contour roll. To do this, we have to create another sketch with a spline from here to here, so, and this is the contour. Now I make this, I project as a center line the axis Y, finish sketch, home, and we apply contour roll. The contour roll creates a piece of revolution, not 90 degrees but 270. OK, this is the part from all angles, a revolution part. You can choose the 360 degrees, of course. Another tool is hem, H-E-M. We create a face, this face, OK, and now we use the tool hem with the first applied on this edge, apply, and you see here what is this doing, this tool. We can choose another edge and we obtain a teardrop folding. You see the two folding. The other two can be obtained if I change a little the face by adding some lines to be the same part. So, and so with the splitting this and this and making them construction lines. Now we again apply hem, but on this edge, and the kind is rolled, as you can see. 180, no, 210. Yes, more than 180, 80. And the last one is double folded on this edge, and you have here the double folded. You can change a lot. For instance, the length to be not thickness multiplied by 4 but by 14. Okay, and you have a larger folding. Good. The next tool is bend. We start by creating a face. This is the base of the face. Okay. Creating a new plane. Selecting to create a sketch. The sketch I want to be outside of this. When you look perpendicular, and again face, visibility, and now we apply bend. I have to select edges, this one and this one, for instance, and now to variant. 45 degree seems to be the default. Let's see what happens. It happens that we connect the two faces with a slope face. Cancel. Control Z. And the other variant, selecting the same edges, this one and this one, is fixed edges, not 45 but fixed. Okay, and this is the result. You can choose anyone you want. Another tool is fold. We can start it by creating a face, of course, and drawing a line on the face, the face of face, and then we apply fold. We have to choose which way to be folded, so with some options you can explore them, and the angle of 66 apply. You see, this is what you can obtain. You practically bend a sheet metal to obtain such part. Now, having this part created, we choose this face. We draw a closed contour like this one, and we fillet a corner to be more interesting. Finish sketch, and now we can cut the part with this contour by using the tool cut. We select so, and we select all. The direction is good. Okay. And you see what happens. When you look from here, you see that contour. But the result is not so well. So I can decide to choose another options. Cut across band. Okay. And now it is like you firstly cut the part and then you apply the fold here. Interesting, isn't it? Another variant is to choose cut normal. Okay, and this means that only the flat part is cutted like so. You can also choose to make not a cut but a contour on a distance. If the part is 0.5 thickness, by dividing the thickness by 2, we can obtain this. Excuse me. Okay. And you see what happens. If you choose cut across band, you obtain this. Yes. All of them are very interesting, and you can choose which one to use. Let me place in a position. Okay. Another tool is corner seam. We create a special, very special face like this one. It is very special because I cut a corner. Now face, since we have a closed contour, we can apply face. Flange on this edge, all edge, but not 25, but say 10. Apply. Another one at this edge, apply, and another one on this edge. Okay, we obtain something not so nice. Yes, there are some overrides and so on. To go to a proper situation, we use corner seam. All we have to do is to select to parallel edges like this and to apply. And you see, this is more interesting and useful. Another is to select this and this, and we obtain a nice corner. Good. An interesting tool is punch. We can use it, but I have to enlarge this face a little. To do this, I go to the sketch and I move a line. Good. And now I create a sketch on this face, placing a point somewhere here. Finish sketch. And then we apply the punch tool. This tool offers us some already made contours, usual in different industries, like you see here, and I choose keyhole with the extension IDE. Open, and the point was found. Finish, and we have such a standard punch in our part. Good. To demonstrate the tool unfold and refold, we use the same part we created, lofted flange. Unfold asks us to select a face and to select the bends which are to be unfolded, to be unfolded, yes. Okay, and now you see a flat pattern. The advantage is that we can now create a sketch on a flat face to draw, say, a circle, one or more, for instance, equal circles in radius, equal in radius. Finish sketch. Now punch, not punch, cut, selecting this, this and this, and all. This is the direction. Okay. The program knows better. Good. And now I refold the part. I choose again a stationary face, this one, and bends. 1, 2, 3, 4 bends. Okay. And you see that the part has 3 holes. Very nice. Good.